Hello everyone, good evening to all. Is the audio and video clear to all? Is the audio and video clear to everyone, guys? Is the audio and video clear to all, guys? Very good evening to everyone, guys. So in the today's session, we are going to start with the design of shear problems based upon the design of shear. Now, from this topic, a lot of questions are asked. And this topic, students tend to make mistakes as well because they do not understand the concepts behind the design of shear. So in this session, we are going to do a GATE previous year question through which we are going to understand all the concepts required to solve any problem which is asked from this topic. So if you attend this session properly and fully, with full sincerity, you are going to understand all the concepts regarding the design of shear and you are not going to make any mistake. That will be from any top question that will be asked from this topic. Is it clear? Structure analysis, we can start, no problem. We can plan another series on structure analysis also. There is no problem at all. Okay. We have a few faculties. We can see when a structure analysis series can be started. Kindly check what are the classes which are conducted by Mohammad Ansari sir. Okay, Ansari sir might be conducting any series on structure analysis currently. You can check it over there also. There might be some ongoing series on structure analysis by Ansari sir also. Okay. So now let us start. So I will introduce myself. My name is Rohan Goyal, everyone, and I scored an All India rank of 96 in GATE 2020. And prior to that, I scored an All India rank of 366 in GATE 2016. I have a master's degree in structural engineering from IISc Bangalore, and these are the subjects that I teach at Gradeup. So read the first problem and let us see if you are able to answer me this question. This is a GATE previous year question, guys. It is a GATE previous year question, guys. A very good question, and this type of question has been asked repeatedly in GATE examination. This type of question has been asked repeatedly. Read the question. A reinforced concrete beam of rectangular cross-section of width of through 30 mm and effective depth of 300 mm is subjected to a maximum factored shear force of 120 kN. The grade of concrete, main steel and stirrups are given to us. For concrete, main steel and stirrup steel. For the area of the main steel provided, the design shear strength tau c as per the IS 456 is 0.48 Newton per mm square. This is 456. Okay. The beam is designed for collapse limit state, and the spacing of 8 mm two-legged stirrups to be provided is Shivam. There is still a lot of time for your GATE 2022. You have GATE 2021 prior to that. So I think you should concentrate on GATE 2021 first, and then you shall move towards GATE 2022. You have 2 months for the preparation for GATE 2021. Give your best, try your best for GATE 2021 first, and after that you shall think about GATE 2022. Okay. Okay. So now you have to find out the spacing of two-legged stirrups that shall be provided for this beam. Okay. Now let us understand the concepts behind how to design a section for shear. Now in the step 1, while designing any section for shear, the step 1 is we find out the nominal shear stress. Nominal shear stress. which is tau v. Now this tau v is equal to V shear force, factored shear force upon BD in working stress method, or so this is factored shear force in limited method and working shear force, that is V upon BD in working stress method, right? This is your nominal shear stress. And now this tau v value shall not be more than tau c max. If it is more than tau c max, then the section is redesigned. Section is redesigned. And your tau v, if it is less than tau c, which is given in the question also, if it is less than tau c, then we provide minimum shear reinforcement. Minimum shear reinforcement. Then we provide minimum shear reinforcement. Okay. So let us find out first. Let us do this much. Let us find out what is the nominal shear stress in this numerical. So we are given in this numerical, the given data is, what is the given data in this numerical, guys? Read the numerical. So we are given, width is given as 230 mm. Effective depth is given as 400 mm. 400 mm. Factored shear force is given as 120 kilonewton. Okay. And tau c value is given as 0.48 Newton per mm square. Okay. Rest is the grade of concrete, grade of main steel and grade of stirrup, which is given to us. And we are provided a two-legged of 8 mm dia stirrups. So, two-legged 8 mm dia stirrup, and we are given M20 concrete, right? Fe4.5 main steel and Fe250 stirrup. Fe250 stirrup. And we are asked to find out the spacing of the main reinforcement. So see, this is the question. Up till now we have understood what is the question is given to us and what do we have to calculate. So up to this point we have just understood the question. We have just been able to understand the question, what the question is given to us. Okay. Now let us proceed with the design of shear. So the step one, we are going to find out the nominal shear stress. We are going to find out the nominal shear stress, which is equal to tau v is equal to Vu upon Bd, which is equal to Vu is 120 kilonewton given to us into 10 to the power 3 converted into Newton divided by 230 into 400, which is equal to how much? Which is equal to how much? 1.3 Newton per mm square, and this tau v is greater than tau c. This tau v is greater than tau c, which is equal to 0.48 Newton per mm square. So for this tau v, this nominal shear stress, we have to design the shear reinforcement. So step 2. Now for what value of the shear force shall we design our shear reinforcement for? So design shear reinforcement is designed to carry Vs shear force. Is designed to carry Vs shear force. What is Vs? Vs is equal to tau V minus tau C into BD. What is it equal to? 1.3 minus 0.48 into 230 into 400. This is in Newton, converted into kilonewton into 10 to the power of minus 3. It will come out to be equal to 75.84 kilonewton. So we have to design the shear reinforcement for this much of shear force. So we have to design the shear reinforcement for this much of shear force. Now let us design the shear reinforcement. So step 3, design of shear reinforcement. Now this shear force is equal to D upon SV into ASV into sigma SV in working stress method, and it is equal to D upon SV into ASV into 0.87 Fy in limit state method. So since it is a working limit state method, so our VSU, that is 75.84, which is equal to, so this is in, since our is a limit state method, so 75.84 into 10 to the power of 3 is equal to, D is 400, SV we have to calculate, into ASV is 2 legged of 8 mm dia reinforcement, pi by 4 into 8 square, into grade of shear reinforcement is FE 250, so Fy is 250. So from here your SV will come out to be equal to your SV will come out to be equal to 115.32 mm. Now you have to check. It shall not, now you have to check. It shall be less than. It shall not be more than SV maximum. That is the minimum shear reinforcement corresponding to minimum shear reinforcement. It shall not be more than this value. So step 4, check for minimum shear reinforcement. Check for minimum shear reinforcement. See guys, this is a GATE previous year question guys. You have to do all these checks. Otherwise, you are not going to get the right answer. So the check for minimum shear reinforcement is ASV upon B into SV shall be greater than equal to 0.4 divided by 0.87 Fy. ASV is 2 into pi by 4 into 8 square divided by B is 230 into SV shall be greater than equal to 0.4 divided by 0.87 into 250. And from here your SV shall be less than or equal to how much? Shall be less than or equal to 237.67 mm. So our SV we have calculated is less than 237. So we will provide a spacing of 115. So B is the right answer guys. B is the right answer everyone. Clear? B is the right answer. Now in the next question it is asked to us that the beam is subjected to a torque also, whose factored value is 10.9 kN per meter. So the stirrups have to be provided to carry a shear force of So what is the equivalent shear force when the beam is subjected to torque as well? What is the shear force? Tell me, guys. Tell me, everyone. So what shear force are you going to design the shear reinforcement for when it is subjected to torque as well? So for this, you have to design for equivalent shear force, which is equal to Vu plus 1.6 T upon B. So Vu is 120 plus 1.6 into torque is how much? 10.9 divided by width is 0.23. So it will come out to be equal to 195.82 kilonewton. But the shear reinforcement will be designed for VSU, which is equal to VEU minus VC, which is equal to 195.82 minus tau C into BD, which is equal to 195.93 minus tau C 0.48 Newton per mm square multiplied by 230 multiplied by 400 into 10 to the power of minus 3, which will come out to be equal to 151.67 kilonewton. So you have to design the shear reinforcement for 151.67 kilonewton, guys. Is it clear? Is it clear, guys? Is it clear to all? Is it clear to all? So let me introduce you guys to the courses which are offered at Gradeup, guys. So we have Gear-Up course, which is a basic concept building course. So if you want to revise the entire GATE syllabus for GATE 2021, subscribe you to this course. Next is your rank up course. If you want to improve your GATE score, if you want to improve your GATE rank, you can subscribe to the rank up course for GATE 2021. And this is the Vision 2022 course, which if you are aiming for GATE and ESC 2022, you shall subscribe to this course. Okay. And since in this class I have seen that your shear concepts are very weak, then I would really recommend you guys to join this Gear Up course, because you need to know the concepts for the design for shear in a much better detail. Okay. And these are our faculties who will be guiding you through your journey. Okay. And we have 60 plus students from Gradeup in top 100. These are all our past achievers, guys. And with Gradeup Super, you get unlimited access to all the structured live courses. Now, if you subscribe to the Gradeup Super, you get access to all the courses, unlimited access to all the courses which are offered at Gradeup, guys. So you can subscribe to Gradeup Super as well, which is a better option. So you will have 6 month, 12 month and 24 month subscriptions in Gradeup Super. For any doubts regarding the subscription, you can contact on this given contact number, or you can also drop an email on this given email address. Okay. And with Gradeup Super, you get unlimited access to all the structured live courses and mock tests which are offered at Gradeup, guys. So what for RCC JEE? Shivam, what for RCC JEE? For SSC JE, there is AE and JE foundation batches. Okay. For SSC JE, there are AE foundation batch. We have JE foundation batch, and we have dedicated batches also for respective preparations. Okay. We have dedicated batches also. You can check on the Gradeup app. Okay. You will find all these courses over there. Okay. We have n number of courses for SSC JE also. Clear? So that's all for the today's session, guys. Thank you. Goodbye. Yes, in civil engineering itself, Shivam, we have n number of courses. We have JE Foundation. Right now, we are starting with the JE Conventional batch as well. Okay, the enrollment for the JE Conventional batch is also open right now. Yes, yes, right. So thank you. That's all for the today's session, guys. Goodbye. See you in the next session, guys. Bye, guys.